Hey, good morning, boys and girls. Happy Sunday. Welcome joining into Tomato Cube MakeCode Arcade series. And today, before we get started, to our Indian friends, Happy Deepavali. So today we are covering the chapter 5, which is gonna be a talk about the programming concept part 1. We have a lot to cover today, so I'm gonna go ahead and get started right away. In today's programming concept, we will cover the following agenda. The first one is we will talk about what is programming in general, and then we will talk about the programming concept variable. Then the second programming concept that we will cover today is the mathematical operations and calculation. And then the last programming concept that we will learn today is the logic. What is programming? If you have done programming before, you might have seen code like this. It looks like some English sentences, which is readable, but might not be fully make sense to normal human. Or even if you have not done programming before, you might have seen it in movies, especially movies that talk about hackers or utilizes some advanced technology. So if you stare into the screen of the programmer inside the movie, you will see lines of text like this. And here's another example. Can you guess what is this code? This is part of the code written by the programmer to create the MakeCode editor that you are using now. So what exactly is coding and how does code work? So code like this is a set of instructions that you give to a computer. In this case, I would like to give an instruction to the computer to display hello world on the screen and also to display some information about the person. And as you can see, this code or this instruction is written in English and is pretty much human readable. So we put this code inside a computer and let the computer to process it. However, computer is not like us. Computer is not human. Computer is an electronics object which does not speak English. Just like any electronic devices, computer can only understand electronic signal, which is either on or off. So if the electronic signal is on, it's represented by 1, and if the electronic signal is off, then it's represented by 0. So computer and all the electronic devices, they speak their own machine language, which is either 1 or 0. So this 1 and 0 that spoke amongst the machines is also called as binary code. So since computer only understand 1 and 0, how does it understand the code that we wrote for it? So computer has a processor or a compiler which can help to turn our instruction into their machine language, which is in 1 and 0. And once it's in 1 and 0s, the computer will be able to understand it and then performs the actions that we ask it to do. In this case, the computer is displaying out the text hello world and also the detail about the person. In summary, code is a set of instructions that you give to a computer. And the process for you to design and create the code is called programming. Do you know that code does not exist only in your computer? Code is actually everywhere around you. In your smart TV, in your vacuum cleaner, in your microwave, in the car and security camera, all these electronic devices have a lot of codes running in them. And then if you look further, we also have a self-driving car. And of course, self-driving car will require even more codes than a normal car in order to function. And in the air, we have airplane and the whole airport system, including the air ticketing system. And then in medical field, it uses a lot of technologies which require coding as well. Then we have a factory that manufacture all the products around us. So all these systems, engines, robots, software and hardware requires coding in order to perform the feature or the actions that we would like it to do. And of course, gaming as well, which require programmer to code the games. And this also includes a classic retro MakeCode Arcade that you are familiar with. Like human language, programming has many different languages too. So why are there so many different programming languages? That's because certain programming language function better in certain scenario, and sometimes it's up to the programmer's own preference. For example, JavaScript and TypeScript are popular in doing web-related development, and Swift is for mobile development in Apple iOS, and etc. However, it does not matter which programming language you're using or learning. The fundamental programming technique is the same. So if you master one of the programming language, you can pick up the rest easily. So despite there are so many programming languages out there, we already know that the fundamental of programming technique is similar. So if we can learn them, we'll be able to apply them across all the other programming languages as well. We learn this programming concept so that it can help us to create a program that we have in mind. So in our case, we want to learn them to enhance our coding skill in MakeCode Arcade so that we can create a more complex game. The first concept we are learning today is called variable. And actually we use variable a lot in programming because that's how we ask the computer to remember things. So for example, I created a sprite character called Dino, and there are some informations about Dino. The Dino is 8 years old, and Dino is living in the forest, and Dino loves pizza. And Dino can eat 6 pizzas every day. So I would like to tell these information to my computer and let the computer to store it. How do we do it? We use variables. So you can imagine variable is like a container or a box which you can use it to keep things. In order to ask the computer to remember Dino is 8 years old, I created a variable which looks like a box and I name it age. So this is a variable that's called age, and I'm gonna store a value 8 in there. And like I said just now, 8 is called value. So anything we put inside the box is called value. And then the next information that I would like to tell the computer is that Dino lives in forest. Since variable can only keep one value, I need to create a second variable. And in the second variable, I will name it home, which is gonna store where my Dino lives. And Dino lives in forest, so I'm gonna put a forest inside the box. And then the third information is Dino loves pizza, so I will create my third variable, and I'm gonna call it favorite food. And the value inside this box is gonna be pizza. And the last information is Dino can eat 6 pizza every day. So I'm gonna tell the computer by creating the fourth variable, and I name it daily pizza amount that Dino eats. That will be 6. So now I have 4 variables. And how do I code that in my computer? I'll say variable age, var stands for variable, and equals to 8, meaning I'm assigning value 8 to my variable age. And then the second variable will be home and equals to forest, which is the value for my variable home. And then I have a third variable called favorite food, and the value will be pizza. Then the last variable is daily pizza amount. So the value for that is 6. Now I have created the instructions to store the 4 variables to tell the computer the 4 informations that we need to store. So you might be wondering, how come some of the values has a double quote around it? If you pay attention on the values, for age and daily pizza amount, these are number and numeric. And then for home and favorite food, the value is a type of text or string. So for value that is a type of text or string, we will need to double quote it. Now that the computer has all these informations with them, we can ask computer, how many pizza does Dino needs to eat every day? Then the computer will go to the variable daily pizza amount and tell us that the value is 6. So that's how variable is being so useful for the computer to store the informations and also to retrieve the informations. Now, how do we create variable in MakeCode Arcade? Let's create the same informations that we showed earlier on, the 4 informations or the 4 variables about Dino. Let me switch over to MakeCode Arcade. So over here in my workspace, I have created a sprite with a background and a tile map. The next thing that we need to do is to create the 4 variables. To create the variables, we go to the variables drawer and select make a variable. Now, if you recall, the 4 informations that we need is the age with value 8, and the second variable is home with the value forest, and the third variable is favorite food with the value pizza. Then the last variable is the daily pizza amount, which is 6. So go back to the MakeCode Arcade. The first variable is age and hit OK. So now I can go ahead and set my age to 8 into the value box. The second variable is home, so I'm gonna create another variable and name it home. Hit OK. So let's set a value for home. So drag this block into my onStart, and if I try to type forest, it won't let me. Remember, there are 2 types of variable values that we have. One of the value is number and numeric. Another type of value that we have are string or text. So in order to insert a string or text into the set value here, we need to utilize a text box, which is under text category. And a text box looks like this. It has a double quote. So drag this box or block into the value box over here. Now go ahead and insert forest. That's how we insert a text value into a set block. So now we have 2 variables, and the third one is favorite food. So make a new variable and say favorite food. Drag the set favorite food into onStart. And remember, favorite food is also a string or text value. So we need to go to text category, drag out the text block, put it inside the value box. Now we can insert pizza into the value box. Then the last one is daily pizza amount. So let's create that variable, daily pizza amount. And if you notice, when I type daily pizza amount, I tend to use an underscore in joining the words together. The reason is, in programming, when we talk to a computer, it's a best practice if we use only one word. So when we talk to a computer and we want to give something a name, we try to join everything together to become one word. There's nothing wrong in MakeCode Arcade if you type it this way with space, because MakeCode Arcade engine has already taken care all the spaces that we have in the name. So before we pass it to the computer, the space has already been taken care of, so in MakeCode Arcade it's totally fine. However, just to remember, in other programming language, this might not be allowed. So the best practice that we normally do is to add an underscore in between the words so that we can join them together to become only one word. Alright, so in this case, my last variable is daily pizza amount. So go ahead, hit OK, and set the daily pizza amount to 6. Alright, so that's how we create the variables in MakeCode Arcade. Then the next question would be, how do you want to use them? So let's say if I want the dinosaur to tell me this information by displaying the text one by one, just like the dinosaur is telling me a story about himself. And I can add a button control, so meaning that if I press an A, I would like dinosaur to start telling me a story about himself. In order to do that, first thing, drag a controller block from the controller drawer, and then I'm gonna utilize sprite say. So drag the sprite say block change a sprite to Dino and say, hi, I am Dino. And let's put some time for it. Let's say for 1 second. Let's see if this works. Let me click A. Hi, I'm Dino. Alright, 1 second is a bit too fast. Let me change that to 2 seconds. Okay, so the next thing, I'm going to utilize the variables that we have created. So after saying, hi, I'm Dino, the next thing is we want Dino to tell us his age. So let's duplicate the say block. And in this one, I'm gonna say, I am 8 years old. So 8 is coming from a variable age. So how do we join the text to form the whole sentence? So I'm gonna utilize another block from text category that says join. So if you look into this, join can join multiple texts together. So I'm gonna use that and place it inside the say block. And instead of saying hello world, I'm gonna say I am 8 years old. 8 is coming from age variable. Go to variable drawer and drag the age block and drop it here. So I am the age years old for 2 seconds. Okay, and in between these two blocks, remember to put a pause so that the text won't go past too quickly. So I'm going to put a pause in between, and the pause should be as long as the say that I have over here, which is 2 seconds. And put one pause here, and let me try to press A to see what happened. Hi, I'm Dino. I am 8 years old. Alright, so we managed to join the text together with the variables to form a sentence. Let's continue to do the next one. I'm gonna copy or duplicate these two blocks. I'm gonna duplicate the pause for 2 seconds, and I'm gonna duplicate the say block. And then I'm gonna say I live in forest. So instead of age, I'm gonna change that to home. And I don't need years old at the back anymore. I'm just gonna say I live in the forest. Let's try this one out. Hit A. Hi, I'm Dino. I am 8 years old. I live in forest. So far so good. So let's do the last one and tell how many pizza does Dino eat every day. So let me duplicate the pause again and duplicate the say block. Let me drag the whole canvas down further. So Dino says, I eat daily pizza amounts. So I eat 8 pizza every day. Okay, so this is a longer text, so I'm gonna make the text to stay there longer, maybe 5 seconds. So let's try it out. I live in the forest, and the last one, I eat 6 pizza every day. So far so good. So that's how we can display the information by utilizing the variables. So we store them in the onStart block. We assign the value over here, and then we can use them in the program anywhere we want. And let's say if I want to change the age to 9 years old, I can just come to here and change the value to 9. And immediately it should be reflected everywhere in the code. Hi, I'm Dino, and I'm now 9 years old. The next programming concept that we want to learn is mathematical operation. It is very important to know how to do calculation in game development because we use mathematics a lot. For example, in the Pac-Man game, we need to keep track how many food is left. So we use mathematics to do the calculation. And besides that, we also need to control how fast should the ghost move for each difficulty level. So for beginner level, the speed might be slower, and then eventually as it go higher level, the speed will become faster. So all this is being controlled by the use of mathematical operation. So we have learned how to create variables so far, and we have created a couple variables for Dino. I'm gonna utilize the age variables to showcase how can we do mathematical operation in MakeCode Arcade. So for this example here, let's add a feature. When we click a up button, we want to increase the age of the Dino by 1 year. And then if we hit on the down button, we will reduce the age by 1 year. To increase the age by 1 year every time the up button is pressed, we utilize the mathematical operation. We say set the age equals to age plus 1. So the age plus 1 over here is a mathematical operation. And then in the MakeCode, we will pull out the set block. Similarly, we will set age to age plus 1. So let's say if dinosaur is 9 years old now, it will become 9 plus 1, which is 10. And then if you want to reduce the age by 1 year, we do something similar. We set the age, but now instead of plus 1, we say age minus 1. So let's try it out in MakeCode. In the MakeCode workspace, let's go ahead and drag out a on button press. So I'm gonna change on up button press. Let's go ahead and increase the age by 1. So we will do the variable set, and we will do set age to the mathematical operation, which is the age plus 1. So I'm going to go to math drawer and drag the math operation block that return the sum of two numbers. We drag this and place it inside the value box. And then I'm going to drag the variable age into the first value box, and the second value box I'm gonna insert value 1. So when up button is pressed, it will set the age becomes age plus 1. So let's try it out. The age of the dino right now is 9 years old, and when we ask it to start speaking, it will say, "Hi, I'm Dino. I am 9 years old." Okay, so now let's go ahead and hit the up button. Then press A one more time. "Hi, I'm Dino. I am 10 years old." So you can see that whenever I press the up button, the age will increase by 1. So let me click one more time and hit A again. "Hi, I'm Dino. I am 11 years old." Okay, so the up button is working. So let's go ahead and do the down button, which will reduce the age by 1. So I'm gonna go ahead and duplicate it and change the on up to down, and then set age to age. Instead of plus 1, I will change it to minus 1. So let's try it out. I'm gonna refresh it. So now when I ask dinosaur to tell me his age, it should be 9 years old. Okay, then I'm gonna hit on the up button one time and hit A one more time. So now it becomes 10 years old. And if I hit down button and hit A again, Dino is gonna tell me he's 9 years old. So if I hit down button twice, how old will dinosaur become? Dinosaur will become 7 years old. So my up and down button is now working, and I'm using the mathematical operations here to do the subtraction and addition. Right now, when we hit the up and down button, it will change the age for the dinosaur. But the amount of the pizza that the dinosaur eat doesn't change. So how about we do something about it? Let us change it to become the age multiplied by 2. So meaning that if the dinosaur is 3 years old, the amount of the pizza that he needs to eat every day will be 6. And then if the age of the dinosaur is 5, then the amount of the pizza that he needs will be 10. So the amount of the pizza will always be the double of the age. So how do we add this part of the code into the existing code that we have? So first of all, in the onStart block, Instead of set daily pizza amount to a fixed value of 6, we will change that to the double of age. So go to the math operation and take out the multiplication block and drag it on top of the value box and change the value to age times 2. So age is gonna be from the variable block, and I'm gonna drag it inside the value box. Okay, then multiply by 2. So let's do a quick check. Hit A. Hi, I'm Dino. I am 9 years old. I live in the forest. I eat 18 pizzas every day. So that is correct. 18 is 9 times 2. 9 years old times 2. Okay, but that's still a problem. So if I hit up button, now I will become 10 years old. And by right, I should eat 20 pizza instead of 18 pizza. So how do we fix that? So whenever we hit the up and down button, we change the age by 1, either +1 or -1. But we didn't ask the computer to change the daily pizza amount. So we need to do that in our up and down button. Whenever the age change, we need to change the daily pizza amount accordingly as well. So what we need to do is just to duplicate this block that we have in the on start and place it inside the on up button press and also inside the on down button press, so that every time the age change, we change the daily pizza amount according to the age as well. Alright, let's try it out. So the first one is I am 9 years old, and yep, I live in the forest and I eat 18 pizza. So let's go ahead and hit the up button twice to increase the age to 11. So try A. I am 11 years old and I am eating 22 pizza every day. Cool. So let's try out the down button. So let me reduce it by 3 years old. So I was 11 years old. So if I hit 3 times, 1, 2, 3, how old am I now? I'll become 8 years old. I live in the forest and I eat 16 pizza. Yep, I'm younger now, so I eat less pizza. Okay, so that's how we can utilize mathematics to play around with the game that we are going to create. So far, we have learned 2 programming concepts. The first one is variable, which we use it to help us to store the value, and we can also call the variable in order to retrieve the value for the variable. And then we also learn how to do mathematical operations. We use it to interact with the variable, and we can also use it to help us to perform the calculations that we need in the game. And in the later chapter, we will cover more complex mathematical operation. Before we move on to the third programming concept, let's do a quick quiz. Do you recall what are the variables created in this food counter program earlier on? Yes, we have an age variable, and then we also have a home variable to store where the Dino live, and we have a favorite food variable, and lastly we have the daily pizza amount to tell us how many pizza does Dino eat every day. And do you know that besides these 4 variables, there are other variables that has been created by the system that we can use? Some of the common ones are like the lives. This is life variable, and then we also have a score variable, and we also have a countdown variables. We don't have to create this variable explicitly. They have already been created by the system under the toolbox. So if you go to the MakeCode Arcade, under the info category, you can see that we have a score and set score to, and then there's also live, that's set live to. So all these are actually a type of variable as well. And the difference is this has already been created by the program, and we can just use it directly. Now let's move on to the last programming concept for today, which is logic. So there are 3 main things under logic that we are going to learn today. The first thing is condition, second is comparison, And the last one is Boolean operator. So when we come to logic, we are using all these three attributes very closely. So let me explain to you what is a condition. You can imagine condition is like you're in front of a traffic light, and there is a condition that says that, hey, if it's a green light, then you can go ahead. But if it's a yellow light, then you need to slow down. And then lastly, if you see a red color light, then you have to stop. So these are the three different conditions that we have in our daily life. Similarly, with the computer, we can ask the computer to follow certain conditions or follow certain rules that we set. So let's try to build this real-life example into our MakeCode Arcade. So here's my MakeCode Arcade with a different project. Let me go through the on-start block quickly. In this project right now, I have two sprites. The first sprite is a policeman that looks like a little cute police over here in the middle. And then I have a second sprite, which is a car that indicate the player, which is me, which I am the driver inside this car. And I set the driver positions to be somewhere at the bottom over here. And then the next thing, if you notice, I have a new variable that call traffic light. So I set the traffic light to be red, and then I set the background to red for 5 seconds. And after 5 seconds, I set the traffic light to yellow. And then at the same time, I also set the background color to yellow. And then it wait for another 5 more seconds. Then now I change the traffic light to green and set the background to green. So let's refresh it. The screen is red in color, indicate the traffic light is red. Then 5 seconds later, it becomes yellow. Now green. Okay, and what I have additional things over here is when A button is pressed, I'm gonna move the car with acceleration y minus 100. So that means it's gonna move outward. So when I hit A, my car will accelerate upwards. So this program works perfectly, but it doesn't follow our traffic lights rules. Because right now, whenever the A button is pressed, the car will move regardless of the traffic lights. So meaning even though if it's a red light like this, if I press button A, the car can move. So I want to add a traffic light condition and say that, hey, if the traffic light is red or yellow, the car should not move. And maybe the police will say stop or wait. And the car can only move when the lights turns green. In order to add that conditions, I need to add a check under my A button press. So let's empty out my A button press. And inside my A button press, whenever the button A is pressed, it will check what is the color of the traffic light. So to add those check or those condition, we go to the logic block and drag the conditional block over here that says if true then, drag it and put it inside the on A button press. So this conditional block says that if true, then do something. So true is the conditions that we will add in. We will say that if traffic light is equals to green, then police say go and the driver can accelerate. So to create that traffic light equals to green conditions, I go back to the logic and use the comparison. The comparison should be this, but this one over here, you can see that there's a double quote because traffic light equals to green is a text, it's a string. So we need to do a string comparison here. So we will use this block. So drag this block inside the true block. And then I'm gonna drag the variables traffic light into my first value box and say if traffic light equals to green, then my driver can accelerate. And then also I can ask my police to say go. So let's drag out my sprite say, change my sprite to police and say go. Okay, let's do a quick check. So right now is red light. If I press A, the car will not accelerate anymore because there's a condition check inside my A button press and say that hey, it's not green. Only green, then it can go. Okay, so this is my first condition. Let's create my second condition, which is a yellow traffic light. So the second condition can be created by adding a plus sign here. So it will say else. So if traffic light is equals to green, do this, which is set the driver acceleration and police say go. Otherwise, it would do this. In our case, we want it to be more specific. We want to say if the traffic light is equals to yellow. So I'm gonna hit one more time, and then now I can create my own statements. So I will say else if traffic light equals to yellow. So go back to the logic drawer and drag out the string comparison one more time, and place it inside here, and say variables traffic light equals to yellow. Then let me duplicate this one and say police say wait. Okay, and then the last condition is gonna be red. So I'm gonna hit one more time, and I'm gonna duplicate what I created on top. Just say else if traffic light equals to red, and then police will say stop. Okay, and I don't need the else statements at the end here, so I just go ahead and click the minus sign. Okay, so let's take a quick look again. If traffic light is equals to green, then set the driver accelerations to -100, and then police say go. Else, if traffic light is yellow, then the police say wait, and then the car doesn't move because I don't have a set driver acceleration block inside here. And then if the traffic light is red, then police say stop. Okay, so let me refresh it. Now it's red light. If I press A, it will check, hey, traffic light is red, so stop. And then if I press A again, now it's yellow light, it says wait. So now if I hit A again, it says go. Alright, so this is a simple conditions that we have added into our on A button. So whenever button A is pressed, it will check through this condition and react accordingly. And inside the condition block, you might notice that we actually utilize the comparison block as well. This block that we highlighted here is called comparison block. What it does is it's comparing the value of the left side and the right side. So it's helping us to check whether the value of the traffic light variable is it equals to green color. If it's equals to green, then we perform the action inside the first condition block. And the second one is a similar concept. We utilize the comparison block to help us to check if the value of the variable is equals to yellow. If it's yellow, then it performs the action inside the block. So the action of comparing the value or checking whether the left value is equal to the right value is called comparison. Now let me go ahead create another project to demonstrate how do we utilize logic in our MakeCode Arcade. And in this example, I will utilize both the condition and the comparison block as well. And towards the end, we will add in the Boolean operator. So the project I'm gonna create is gonna call color tuner and hit create. Let me show you quickly how does the color tuner works like once everything is coded. So this is a simple color tuner. The color of the background is green to begin with, and if I change the score by hitting up and down button, it will change the color. Right now anything above 0 is green, and if it goes below 0, it will become red in color. And if I keep going out, the color would change based on the threshold that I set inside my program. Okay, so let's create this simple color tuner. Okay, so in my workspace, the first thing that I need to create is the controller so that when I press up and down button, it will change the score. And then only I will add in the condition to display the background color based on the score. So first thing we need to add in the controller up and down button first. So go ahead and drag in the on A button press and change the A to up. So when the up button is pressed, I want to change my score. So score is a variable that has already been created inside MakeCode Arcade. It's under info, so I can utilize it directly. So I can say set score to score +1 to increase it, or I can also use the change score by 1. So change score by 1 is equals to adding 1 point to the score. So let me drag that into my on up button press. And in my on start, let's go ahead and set the score to be 0. So at the beginning, the score is 0. There you go. The score is 0. And when I hit up, the score increased by 1. And hit down, nothing happens. So let's go ahead and duplicate the button press. Change the up to down. And now change score by 1. I will change it to -1. So change score by -1 is similar to the set score equals to score minus 1. So let's try it out. Up, go, the score go up, and then hit it down, the score go back down. Now that I have my button and my score is working accordingly, the next thing that I would like to do is to let the background color to change according to the score that I set. The changing of the background color or the screen should happen automatically whenever the score change. So to do that, I need to drag in another block that says on game update. So this block allowed me to run the code inside this block anytime when the game is running. For the onStart block, we know that code inside the onStart block will only be executed when the console power up. So on the console power up, it will run the code inside the onStart once. But in our case, we want the code to always check what is the score and change the background automatically. So in that case, I need to utilize the onGame update block. So inside my onGame update block, I will add in a condition to check what is the score. If the score is more than 0, I want to set the background to green. If the score is less than 0, I want to set the background to red. Okay, so let's go ahead and drag in the condition block. If true, then. And then I need to do a comparison to check what is the score. If the score is less than 0, then set the background to red. So to do the comparison of the score, we are going to utilize the comparison block. In this case, score is a value or numeric, so I'm going to use the first one. Either the first one or the second one works. Okay, so I'm going to drag the first one, and the left value is going to be the score. So if score right now is equal, so we are going to change it if score is less than 0, which is this one here. So now if the score is less than 0, then set the background color to red. So I'm going to the scene and get the set background color and change it to red. I think we can try out the simulator. So 0 is black because we didn't set the green color background yet. We only have one condition, which is less than 0. So if it's less than 0, now the screen become red. So go ahead and create our second condition, which is more than 0, and set the background to green. So hit one more time so that we can create the statement. And drag in a comparison block once again. Then we are going to say score equal to 0 or more than 0. Remember, we are doing the color tuner. So if the score is less than 0, we set it to red just now. And if the score is 0 or greater than 0, we want to set it to green. How do we do the comparison that the score is 0 or greater than 0? So in the comparison, just now we were using the equal in our first example. When we do the traffic light, we say that if the traffic light is equals to green or yellow or red, it's doing a comparison to check whether the left value is equals to right value. And then there's also this symbol here. This symbol means not equal to. So if left value is not equals to right, then this symbol is what we use earlier on, the less than symbol. This says if the left value is less than the right value. So in our case is if the score is less than 0, we want to display a red background. And this sign over here with the additional bar underneath the less than symbol, this is less than or equal to. So in our case, we want to do a green greater or equals to 0. So we are going to go with this one here. If score is greater than or equals to 0, then we want to set the background color to green. Okay, so let's go back to MakeCode. Okay, now score equals to 0, so we need to change that to score greater than or equals to 0. And we want to change the background to green. Okay, let's try it out. Now it's 0, so it's green. And if you reduce it, it becomes red. And if you increase the score, it go back to green. So far we have two modes, either red or green. So we can add more color to our program by adding more condition into our on-game update block. Let's say if I want to do a more complex color tuner, and besides the red color that we have right now, we want to add something like if the score is between 0 and 9, it's green, and anything beyond 9, let's say 10 to 19, it becomes yellow, and anything above 19, it will become purple. In our MakeCode Arcade, the first condition say that if the score is less than 0, set the background color to red. The second condition say that if the score is greater than or equal to 0, then set the background color to green. However, we know that in our complex color tuner, we have changed the second condition. Our second condition now says that if the score is between 0 and 9, then set it to green. So it's no longer just greater than 0, but it also needs to be between 0 and 9. So that means that the score has to be greater than or equals to 0, and at the same time, it must be less than or equals to 9. So how do we achieve two conditions in MakeCode Arcade? Now it's time for us to learn Boolean operator. So Boolean operator allows us to take in multiple conditions. So there's two types of Boolean operator. One is AND, another one is OR. The AND Boolean operator in this example take in two conditions, condition 1 and condition 2. The if comparison will return true if both conditions are true. And if you use the OR operator, the comparison will come back as true as long as one of the condition is true. So either condition 1 is true or condition 2 is true, then the comparison result will return true. Let me give you a real life example. For instance, I have two conditions. The condition 1 says that Adam must finish his homework. And then the condition 2 says that Adam must finish his piano practice. Okay, so if mom uses the AND operator and says that, hey, Adam must perform condition 1 and condition 2, then only he can watch TV. So that means that Adam must finish both his homework and piano practice, then only he can watch TV. Mom used AND operator, so that means Adam has to do both his homework and piano practice, then only he can go ahead and watch the TV. However, if mom uses an OR operator, that means mom says Adam must perform either condition 1 or condition 2, then he can watch TV. So that means Adam must finish either his homework or piano practice, then only he can watch TV. So in this case, since it's an OR operator, so Adam will only need to either finish his homework or does his piano practice. He can choose either one. So if he performs one of this, then he can watch the TV. So that's the difference between an AND operator and OR operator. When we use an AND operator, both conditions need to be true, then only we can proceed to do whatever we coded in our block. If we are using an OR operator, it just needs one of the conditions to be true. So go back to what we want to do with our color tuner. We want the score to be in between 0 and 9, then we will set the background to be green. So there's two conditions here. The first condition is the score must be greater than or equals to 0. Second condition is the score must be lesser or equals to 9. So there's two conditions. And in order to make sure the score is in between 0 and 9, we add an AND operator in between. So the score must be greater than 0 or equals to 0. At the same time, it must also be lesser or equals to 9. So we use the AND operator in our MakeCode Arcade. And doing that, we will add two comparisons. So the left side is a comparison that the score is greater than or equals to 0, and the right side is the score must be lesser or equals to 9. So let's do that in our MakeCode Arcade. So let's go ahead and take out this score and add in a Boolean operator that will be under logic. Under Boolean, there's an AND operator here. Drag it into the empty box here. So the first one is the score must be greater or equals to 0. So which is this score over here that we had previously. So I just drop it here. And the second one says that the score need to be lesser or equals to 0. So let me choose a less than or equals to 9. Okay, let me zoom in further here. So you can see that I have two conditions, score greater or equals to 0 and score lesser or equals to 9. So that means the score is in between 0 and 9. Then set background color to green. Then moving on to the third condition. Third condition says that if the score is between 10 and 19. So between 10 and 19 meaning the score is greater or equals to 10. And at the same time must be lesser or equals to 19. So let's add the third condition, and I'm gonna duplicate what I have in my second condition and change the first value to 10. So the score is greater or equals to 10 and score must be smaller or lesser than 19. And I'm gonna change the background color to yellow. Okay, so I have 1, 2, 3 condition right now. The first condition is score lesser than 0, set background color to red. The second condition is between 0 and 9, set background color to green. Then the third condition is between, the score is between 10 and 19, set the background color to yellow. Then the last condition is purple, and purple condition says that the score is greater than 19. So let me go back to my MakeCode. I'm gonna copy this one because this is a simple comparison as long as the score is greater than 19. Then I will set the background color to purple. Okay, so I have 4 conditions. I don't need the last one, so I can go ahead and remove. So I cover all the conditions of the score that I want. So now let's try it out. If I go to negative, become red. If I go up to 9 is still green, 10 become yellow. If I keep going up, let's say more than 19, now it becomes 20. Okay, so in this simple demonstration, we are utilizing the condition block with a combinations of a comparison and a Boolean operator to help us to do the value comparison and also to perform the action according to the outcome of the comparison. So if in the future you need to control your game based on certain condition that you set, that's how you can do it. Before we end today's session, let's take a quick look at the Dino Food Counter project that we worked on earlier on. There is a small problem in the program because as we click on the down button, it will keep reducing the age. It works fine, but as it goes below 0, it will become negative value. So eventually your dinosaur will become negative years old. So that doesn't make sense that someone has a negative years old. So how do we fix it? Can we utilize the condition to say that we can only reduce the age if the age is above 0 years old? Let's do that. Coming back to my project here, I have the on down button pressed, and inside the block it says whenever the down button is pressed, it will reduce the age by 1 year old. If you keep pressing the down button, the age will keep reducing. There's no control over it, because it can go below 0 years old and now it becomes negative 19 years old. In this case, in order to fix it, we need to add a check in our on down button press. So we need to add a condition there and say, is the age value greater than 0? If the value is greater than 0, then only we can reduce the age. So let's go ahead and add that condition check. We say if true then. So we put it around the 2 blocks to say that if a comparison, if the age is greater than 0, then only we can set the age to age minus 1 and perform the rest. If it doesn't fulfill the condition, it won't execute the block inside this condition block. Let's have a look if this fixes our issue. So let me hit on the down button multiple times. Hit A, hi, I'm Dino, I am 0 years old. So if I continue to hit on the down button, it should not reduce the age any further. So it stays at 0 years old. Okay, so that's how we can prevent an event from happening by adding a condition to check whether it fulfills the condition. If it fulfills, then only it performs the actions that we set inside the block. So let's do a quick recap of what we learned today. What is the use of the variable? Variable help us to store information or a value so that we can use it later on in our program. And we can also change the value or retrieve the value inside our program. How do we set the value for a text variable? Remember, we need to drag a string block that has a double quote in it from the text category into the value box in order to set the value for a string variable. What is a comparison block? We use comparison block to compare two values, whether they are equal, not equal, less than, greater than, etc. And the last question is, what is a condition block? So condition block consists of if-then statements, which look like this one over here, the blue color block. It has a if and then, and is used to control the flow of the program. So it functions like a rule check. So if the condition fulfills the rule, then only the program will execute the code inside it. So let's take this one as an example. So it checks first, what is the traffic light? Is it equals to green? If it's equals to green, then only it will run the code inside it, which is asking the police to say go, and then set the driver acceleration to -100. And if the traffic light is not green, then it will go to the second statement to check, is the traffic light equals to yellow? If the traffic light is equals to yellow, then it will ask the police to say wait. And one note, if in the event the traffic light is equals to green and this part of the condition is fulfilled, it will run the code. After running this part of the code, it will not proceed to run the second condition. So once the condition is fulfilled on the first one, it will not continue to run the second condition, because here we say else if. So it will only run this if the first one doesn't fulfill, then only it will go to the second statement. If the second statement still doesn't fulfill, then it will go to the third one. Okay, but if in the event any of this condition is met, they will run the code and then exit from the block. Alright, then I think that's all for today. Please let me know if you have any questions throughout the whole learning sessions. You can always reach us by leaving us a message on Facebook. Alright, so next week we will cover the part 2 for the programming concepts, and coming Sunday our live stream will start at 2 p.m. Alright, so stay safe and see you all next week.